Everyone, welcome back. We're gonna start with reinforcement for columns. Now, when we talk about reinforcement for columns, first we have something that starts from foundation. As you can see it here, those are column reinforcement that they start from the foundation. We call them dowel bars. So in order for columns to start, what we do, we cast the foundation. Yes, when we cast the foundation, there's supposed to be reinforcement to go out. As you can see from, let's see, as a real one, you can see it from here. There will be column reinforcement going out. Look at the column reinforcement, you have it here. This is foundation still. But the column reinforcement will be provided from the foundation. Well, not complete, not till the end. They call them dowel bars. So it kind of a connection. You will provide, look, it kind of coming like this. Later, when the column reinforcement will be provided, they will come beside them and they will link them together. So this is what we call them dowel bars. Dowel bars are the column reinforcement on the foundation, inside the foundation. So how do we do this? In the drawings, we're supposed to have them. So when we start with the columns, we'll start with the dowel bars, then we'll go for the rest. Now, well, let's come to the column reinforcement. This is column reinforcement. Look at inside the columns that we have it. The reinforcement that we have it inside the column, what do we have? We have those, which are the straight bars, and we have something around it. This is, we call it stirrup. So we have stirrup and the main bars. Now, from here you might not understand exactly how does it look like. Yes, why? Because it's not in a plan. But I told you that you will be okay. Things here can be clear, or let's just go for a column reinforcement. In order to see the detailing, because when you're calculating again, you need to imagine first, then you have to go. So this is what we mean by the reinforcement. You have the main reinforcement, which are the vertical ones, and you have something around them, we call them stirrup. So you have the main and the one beside it, which we call them stirrup. So let's make this one bigger. Because you see this one on the plan like this, you're not going to see too many detailings. So when you see the round ones are those, the long one, and the one around it, so which is around the bars, those are the stirrups. We have different type of stirrups, you can see it here. You'll learn those from the reinforced concrete courses. But for us, what? I need to know the size of them, I need to know the length of these bars, and if I want to calculate this one as well, I need to know the size of it, and I need to know the length of it. That's it. And how many of them I have it. The same thing, how many of this one I have it there. So, let's go to the drawing that we have it here. So we have the two bar, the main bars and the stirrups. Stirrup are the one that around it. Don't worry, when you provide detailing for you, provide in English. Now, within the columns, you will see it in this manner. So this one here, this is the stirrup, which means the reinforcement that basically bonding. So I'll change this one to stirrup. Just to understand this one in English. Stirrup. Now, within the column, you will see something like this: 10, 5, 14. 10, 5, 14. That's basically, here we don't have spacing. It's only talking about what? You have 10 long bars. Those are the main bars. They call them longitudinal or the main bars. You have 10 of them. That's basically 10, 5, 14. For the stirrup, which is the one that, as I showed to you, around those, this is what we call stirrup. How does the reinforcement will be provided here? 5, 8 with spacing. For example, this says that it's 8 millimeter. The spacing between them 13 centimeter. We'll talk about this one, discuss. There is another one here, but I'll not talk about this one. So it will be provided in this way. They call 5, 8, 13 centimeter between them. Sure, we have to calculate how many of them, or sometime will be given to us directly. Now, we said 2 bars, 2 main bars, we have it in the column. The main bars are 2 type of bar. The main bars and the stirrup. Remember, we have those are, but those are small. You don't use them a lot. Just few of them will be used there. Now, the numbers are here, the size are here, but the length of them will take it from where? From the floor plan. So I'm gonna show it to you how we calculate the length of the bars for the column. We already know the length of the column start from where? From the bottom, from the floor to the bottom of the beam. Yes, we know this one. But there's something you have to know, that when we casting column, look, if this is the bottom of the beam, if this is here, if it is the bottom of the beam, the reinforcement will always go out. Why? For the second floor column to continue. So when you do column, when you calculate column reinforcement, you have to make sure that you always encounter this extra reinforcement that between the 2 floors. Between the 2 floors we call it. Extension of the bars. So if I show it to you from first floor columns, you mean what I mean? Understand what I mean by those? So look at this. When we do form work, it's clear with the form work as well here. You have a part of the reinforcement going beyond the form work. Why? We have second floor column supposed to join to this one, so you have to encounter this extra in the calculation. So we already know the length of the column. For example, for the first floor, we had 2.4. We're not going to just use 2.4. We have to encounter this one till the top. So this is considered from where to where. If I go back to the drawing that I have it here, let me just go to the section to explain this one for you, to see this reinforcement. If you want to calculate it, how do you think of it? Now, let's say this is the column I have it. The column starts from here. It comes up to the bottom of the beam, yes? But this reinforcement we already know that it starts from the dowels. I'll come back to dowels. Like the dowels will be something like this. This is the dowels we have it that's inside the foundation. And for the second layer, it goes in this manner. So it goes from here till where? Look, not only inside the beam, even above the slab. Why? Because for the second column, for the second story column, when it comes, their reinforcement will be bonded together. So the reinforcement there will be bonded together with the red one there. So this distance here again, minimum 50 centimeter, but according to codes changes. They go for 1 meter, they go for 50 centimeters, 70, 80. And there is calculation, as I said. It will be given to you within the drawings that we have it here. So if I want to calculate, look at here, this is 3 meter. We know already this one, the slab, the height of 3 meter. And I have 1 meter there, the total height the total length of this bar will be 4 meters. So this is how you calculate the total length. You add extra to it. Do you have this extra for the roof? This is one mistake that students do. The columns does not continue there, yes? So you don't have this extra for the roof there. You might have hook, which we can see it from here. This detailing will be provided by civil engineer. We can see it from here. So when you see column reinforcement, remember, you start from where? From the dowel bars. This is the column reinforcement, we have it. We start from the dowel bars. This is dowel bars, look, start coming out from the foundation. Then we have one for the first floor. Look, it encounter that goes above the first floor, which is 3.5. And then we have for what? For the second one. For the second one, you have hook. This is basically the hook at the top, because it does not go out, but it can be hooked in order to make sure the bond is there. This hooking is for bond. It's requirement according to the codes that required for bonding. So as you can see from here, for the columns you have the dowel bars and you have their length here for each story. Now if you see it here, for this 4 meter for the first story, for the second story 4 meter, and if the columns numbers, I mean it's one provided here, yes, so it means that the columns they have the same reinforcement. I can do it for 2 stories together. First, let's take one of them. Let's say I'm taking S2, whatever S2 is there. Let's set S2 here. I have S2 here. S2, how many bars inside it? 10 bar 14. So what do we write? For S2, I'll write that main bar. I'll first start with the dowel bars. Dowel bars. Now dowel bars are what? Dowel bars, the bars that starting from the foundation goes into the column. Now how many dowel bars we have? The same number of bars inside the column. You have 10. You need 10 bars to come out from the foundation. So that length coming from where? Let's type this one first. Dowel bars is still the same size. For S2 we're calculating, they are 14. So it's 14. Now the length, I'll come back to it. How many we have it? 10. We have 10 bars. You can see it from here. 10 bars, their size 14. So I wrote it at 10 bars, size 14. What about the length? I'll go to the detailing here, which provided to me that the length of dowel bars 2 meter. So it's here. It says that the length of dowel bars 2 meter. We'll be writing this one here, 2 meter. It will be calculated by itself, yes, because I did the. Now why it's 0? How many of this I have it like this? We said that if the columns, if this is 25 by 60, 25 by 60. Now how many I have 25 by 60? If they have the same number of bar, 14, I can just multiply it by that much, which I have it here, yes? Let's just check. For example, S3 at 10, 14 inside it. Yes, the same thing. I have it here, S4, 10, 14. I have here, S6, 10, 14. S7, this is 20, I have it there. I have here 10, 14, 10, 14, again 10, 14 here, 10, 14 here. So I can add all of them together. I can say we have 8 columns, 8 columns. They have this one. Can I add all the bars? Now you imagine the rest of them are 14 years. Even this one, it is, which the column size is 25 by 150. The size of them, we have 14, but you can add the numbers here. Like you have to change the numbers. Or when you write the column, you can just multiply it by how many columns you have it here. Up to you. You can add all of them together, or you can per column. This is 25 by 60. How many we have it? 8 column we have it. So I write 8 column we have it there. Well, for the main bar, the main bar inside those 25 by 60, any of them that you look at, we said that 10, 14 is the same as the dowel bar, yes? They're 14, 10. But the length of them will not be 2, the length of them will be here, 4. Now, you realize that if the first floor, the second floor, the ground floor, first floor, they have the same length, you can write it 8 meter. I can write 8 meter, yes? Why 8 meter? Because I have 4 here, I get 4 here. It's for the 2 stories. For the 2 stories, I'm calculating at once. If their lengths are not the same, then you can add them together. Still, why? Because they are the same bars, the same number of bars, you just add the length together. But if someone asks you to calculate only for first floor, I'll write 4. How many columns I have similar? I have 8 columns, they have the same thing. Let's say this is going to be, if I do it for first floor, I'll write it like this, for first floor. Column for the first floor. Because dowel bar, I only have it for the first floor, remember? You don't have for the second floor. Main bar, I can do it for the top second floor separately. Most probably they might be different, sometimes they not be the same, so you can do it differently. Now, we'll come for which one? We'll come for the stirrups. Now stirrups, we said the one that are covering those bars. Well, for the stirrups, something like this, by the way, the names will be this ETR, stand for stirrup. Now, we need to know the number of them, how many we have it in the column. Now, the spacing is given to us, here. Now, in this dimension, in this drawing, I'll provide it to you details. This is 5, 8, 13, 7. Now, this is, according to Turkish standard, there's 2 different sizing. As part of the column, the stirrup are 13 centimeter apart. In other places, 7 centimeter. Well, let's show you another detailing for the column that we have it. Look at here. This is side view of the column. Side view of the column. For what mainly we use this one? For the stirrup. Now, in some codes, they divide the column into 3 zones. This is for the shear reinforcement. Because we have lateral load. You design column, you'll understand this one. I'm not gonna make you responsible for this detailing to know. I'll provide it to you. So there is a spacing. For example, here we use 7 centimeter according to what's given there. It was written like this: 5, 8/13/7. The 7 are for the top and bottom, which I'll provide it to you, and this one will be 13 centimeter. Now, how much is this length? This is the stirrups, yes? By the way, not the height of it. Not the height of it. This is the stirrup. The 7 will be used for this one, for here, and the 13 will be used for the middle. This is where exactly this spacing between them, 13. This spacing between them will be 7. So I should have wrote this one directly here, this 13 here. Now, how much the height of here by itself? How much this height as well? Well, this is code, but I'll not make you responsible to find it. I'll provide it for you. For example, in this we have, for example, let's say 8 stirrups. In here we have 5 stirrups. Or I can give you the distance, but I prefer to directly give you the numbers. So what will happen between me and you when we have the columns, I'll put this detailing and I'll give it to you like this. Provide information like this in order to know for later. So what will happen? You will have an information for each zone differently. I'll write it like this: 5. So let's make it even with the numbers. So I'll say, for example, 10, 5, 8 here. Whatever the spacing will be given, but the spacing, we say we're not going to use the spacing for bill of quantity. Which one I care? The number, how many stirrups I have it, and the length we take it from somewhere else. Here I will write, for example, I have 5. unless it's 3, whatever it is. It will matter. 5, 5, 8. The spacing will be at the end of it. I don't care about the spacing, we care about the number. The first one is the number. Here as well, I'll give it like this: 5, 5, 8. The spacing is 7. So you take the number here, you take this number, 5, 10, 5, the total number of stirrup became 20. So you have 20 here. Now the size of it is 8. We just need the length of it. The length of it will take it from the other plan. Remember, I'll provide this for you, so you don't need to find these numbers. You can do it by yourself. If you have this distance, for example, if this is 2 meter, you'll divide 2 meter by 13 centimeter or less centimeter, so it will be 200 centimeter. Divide by 13 centimeter, you'll get the number of them. Let's say something like this. This is how you calculate the number of stirrups. Don't worry, you will learn this one from the design, reinforced concrete design courses, the spacing, those things from there. But for me, I just need you to read them. So if given like this, you'll take the number, you'll take the diameter. The spacing is for practical. Well, let's come back here. Let's say we have, let's say the number is given. This is 8. This is 20, which is not given in this plan, but I will say that the way that I provided it. Let's say it's given 20. If someone asks where does this 20 come from, I just assume 20 number of bars, stirrups we have it there. It's not given, which is missing. It has to be given. So, but what else is given to me? The length of the stirrup, sure, it's given here. The length of the stirrup here, like this is for this column. The length of it, it's 166. I need this one. The length of it, 166, I need it. Remember, this is for these two columns. If the column is bigger, also the stirrup will be longer. So I have 166, the length of it, which I need. I'm writing it here, 166. How many columns do I have similar? Because they are the same, 25, 60. I have 8 columns, and they will be calculated for the stirrups. You can do for the other columns, what will happen? You will come, you have this column. In this column, you have 2 stirrup. Look at it, you have 2 stirrup. It's important to know this one. There is 1 stirrup here, there is another stirrup here. So when you're calculating the stirrups, you multiply it by 2 within 1 column. It's still 8 millimeter. Look, they wrote it like 8 millimeters you have. The length of it, 248. The number taken from where? From the other drawings, which is supposed to be given to us. How many numbers do you have a day? How many numbers do you have a day? But remember, sometimes you have 2 stirrups inside it. So what will you do? You can multiply the numbers. Here, for example, there will be 40 for this column. Why? Because you have 2 inside it. Because it's so big, so I made it twicely. This is you're supposed to know in calculating reinforcement for columns. For the round one is the same thing. You have only the stirrups are round, but they have still the diameter. You have the diameter. You can even calculate this one. The number of bar inside is the same. So kind of similar calculation we have there for the number of bars. I have 9 bars. For the stirrup, it's 125. Spacing is given, but number is not given here. Remember, number is the first one. So when number given to you, it will be given before here. For example, we're written 20, 5, 8. The others are spacing. We said that 2 spacing. Why? Because according to code, they divide it to different zones for spacing. That's enough for column reinforcement. In the next video, I'll talk about beam and slab reinforcement. Thanks for watching.